Woohoo, we are live. I'm very excited. This is Math 60 Intermediate Algebra. This is section 3.6. This is video number 483 million that we have done from section 3.6, but I think this is the last one. Yay! One more problem stands between us and being done with 3.6. I'm very excited. So here's the problem. You want to hire a magician for a friend's party. There are 2 magicians available on the day of the party. So you can see there's that theme of 2 things. The first magician charges. The first magician is pink. The first magician charges $25 flat fee plus $7.50 per hour, including travel. While the second magician charges more, a $37 flat fee plus $6 per hour, including travel. What is the break-even point for this situation? What the heck is a break-even point? So in this context, a break-even point would be the number of hours for the cost of the 2 magicians to be equal. Magician number 1 cost of magician number 1 equals the cost of magician number 2. Okay, and so cost of magician number 1 is the pink side, and the cost of magician number 2 is the blue side. Woohoo! Okay, so we want to find the point where those 2 are equal. Now, there are other break-even points that are used in a lot in economics and finance. Sometimes break-even point means it's the point where you don't gain anything, you don't lose anything. So you could see why the 2 magicians having the same cost means neither one is more expensive or less expensive. Okay, so let's look at the costs. Let's break them down. The pink magician, the first magician, is a $25 flat fee plus $7.50 per hour. The blue magician is $37. Let's put these in. Plus, ooh, I wrote plus out. I meant to write it. Wait, just a second. I love this thing. I need one of these for life. Like you say something you didn't mean to say, and you just say, just a minute, and you go like this over time, and people forget that you said the thing that was awkward. That would be so amazing. Okay, $37 flat fee plus $6 per hour. Ooh. And we want to somehow figure out how to set them equal. So what I think we need is we need to know how many hours there were. So I'm going to say let H equal the number of hours. In other words, the length of the party plus travel. Okay, so I'm going to use H for that. You could use X if you wanted to. Over on the pink side, I think I've got 25 plus. Now here's the thing. I'm not just going to add 750. It's 750 per hour. This per hour means that next to the 750, I'm going to multiply times H. Because if it's 1 hour, then it's just 750. If it's 2 hours, I have to multiply 750 times 2 and then add that to the 25. So the 25 is just the basic cost, and then this is the part that changes. If you were in economics or finance, we would say this is the fixed cost. Fixed in math means doesn't change. Fixed is like a fixed, it's stuck. And this is the variable cost. Okay, and over here, I've got 37 plus $6 per hour. So that's h. And basically, I want to set these two equal. So now this is interesting because again, I'm being sneaky. And instead of setting up a system of equations, I'm using the information in the problem to help me structure the problem. Where are my two equations? Well, here's the cost of the first magician. Here's the cost of the second magician. And I wanted to set them equal, so I've got that right here. There we go. We just have to solve this. Okay. Once I've got this going, oh, let me do this over here. Per hour means the h. There we go. Parallel structure and all that. Subtract 6h from both sides. I get 25 plus 150h equals 37. Subtract 25 from both sides. And I get 150h equals 12. Okay, and I am going to need another piece of paper because there's some other stuff we got to do. I've got, so this is number 8. Is it really number 8? Wow, we have done so much work. You guys are awesome. I'm awesome. We're all awesome together. Woohoo! Okay, so $1.50 times h equals 12. Divide by 150 on both sides. Now, I could do this in my head. It's not impossible to do in your head. I don't want to. So I bring out my handy dandy calculator. 12 divided by 1.50 equals, can you guys see that? 24. Really? Wow. Wow. So let's stop and think about this. I must have done something really goofy. Let me try that again. Oh, you guys all saw what I did. Okay, maybe using a calculator is not what I should have done right now. 12 divided by 150 equals, thankfully, okay. You all in video land, you all saw the weirdness that I did. I typed it in incorrectly. I was going to say 24 hours. Nobody wants a 24-hour magician party. 8. Still, that's pretty long. But if the magician lives really far away, you could imagine 2 hours to get there, 2 hours to get home, and 4 hours of performing. So 8 hours isn't that ridiculous. Okay, so what does that mean? That means that at 8 hours, that's the break-even point. That's when the two magicians have the cost of each magician is the same. And now here's the thing. This problem said, using the break-even point, decide which magician should be hired if the party plus travel will take 6 hours. So 6 hours. Now this one's very tempting because what I really would love to do is just plug in 6 hours to the cost of magician number 1 and the cost of magician number 2, and then I would know. And in fact, nothing could stop you. So why don't we just do that? Let's take a look at it and then let's figure it out kind of backwards style. I know, no one should trust me with the calculator right now. The problem is the glare means I can't actually see what's on the calculator when I have it so that you guys can see it. So I know that's a great excuse. So magician number 1 will cost $25 plus $7.50 times 6, which equals $25 plus 7.50 times 6, which equals $70. And magician number 2 is $37 plus $6 per hour. 37 plus 6 times 6 is 73. So magician number 1 costs slightly less than magician number 2. So that's we just plug it in and then we know, okay, this one is less expensive. How could we have done this without plugging it in? That is a good question. So let's analyze what's going on. So what's going on is Magician 1 starts off as less expensive, but each hour is more expensive. So has an additional $1.50. See the $1.50? That's the difference between what they charge. The $1.50 means that this magician starts out less expensive, but then charges more per hour, means in the beginning it's less expensive, and at the end it's more expensive. This starts out with a very high, that costs a lot more. In fact, how much more? $12. See, there's that other amount. $12 more to begin with. So more expensive to begin with, but as time goes on, the hourly cost is less and less. So we've got two different magicians. And if we look at the two graphs, we've got a situation like this. And my question is, without graphing, can we figure out which is which? Well, yeah, because if I look at, and this is all a terrible sketch. Let's see if I can get this to go. And I'm gonna use the magic words. You guys ready for the magic words? Not to scale. Magic words. So we've got two lines, which looks like they're heading this way. Notice that 25 is the intercept. 37 here is the intercept. Oop, let me slide it down a little bit further so you can see more easily. 25 and 37 are the intercept, and 750 or 6 is the slope. So we know that, I'm going to claim that the lower intercept but the higher slope, the steeper line, is this one, the pink one. And the higher initial cost but the lower slope is this one. And can you guess, oops, let me move this back up. Can you guess where the break-even point is? You got it. It's right there. Oh, that was exciting, wasn't it? Here's the break-even point. So remember, Magician 1 is the pink one. And Magician number 2 is the blue one. And let's look at the graph. So if the break-even point is right here, and this is H, 8 hours, and we're looking at 6 hours, that would be back here. At 6 hours, the pink magician is slightly less expensive than the blue magician. See that? Notice after the break-even point, what happens? They switch directions. Now the blue magician is less expensive. So if I said, what about 10 hours? At 10 hours, I'd go with the magician. I don't know why you'd want a magician for 10 hours or 12 hours, but if it was more than 8 hours, go with the magician number 2. Fewer than 8 hours, go with magician number 1. So you should hire magician number 1 for a 6-hour party plus travel. The pink one. Kind of makes sense? Kind of woohoo? Okay. That was number 8. Oh my gosh, guys, we're almost done, but we're not quite done. There's one other thing I want to tell you about. Rather than putting it in a silly little 2-minute video, I'm going to kind of smash it on to the end of this video. And that is that in this section, there's a bit of geometry, and there's a good chance that you have probably forgotten your geometry. So I wanted to just give you a little review of geometry and of angles and wonderful stuff like that. So complementary angles are angles that, when combined, create a right angle. So what does that look like? So complementary angles are two angles like this. The two angles go together to make a right angle, which is 90 degrees together. So when you add them together, so if this is A degrees and this is B degrees, A plus B equals 90. Supplementary angles are angles that, when combined, create a straight angle, which is a straight line. So this is this situation. And if this is A, then B would be this whole thing. And in this case, A plus B equals 180. So basically, if two angles are complementary, they add to 90. And if they're supplementary, they add to 180. That's the difference. Draw a line right there between the two. Now, opposite or vertical angles are angles formed by the same two line segments or lines. And so what does that mean? Well, that means that this angle, if this is A degrees, this would also be A degrees. Here, I used 2 for A before, so let me do that. And then if one of these measured B, the one on the opposite side would also be B. So in other words, this angle would match this angle. And this angle would match that. So they're called opposite. Hopefully it kind of makes sense. They're opposite if they sit across from each other like that. So if I have a situation where I have this, what are the other measures of angles? So for example, if I have a little box like that, that tells me that's 90 degrees. Now, if this is 90 degrees, then this one matches because it's opposite. So this is also 90 degrees because this angle right here matches this angle. So far, so good. Then if this is 40, I know that matches. See how these two are across from each other? If this is 40 degrees, then this must be also 40 degrees. And then we just have to figure out what, oh, I shouldn't use green for that. That's too close. Let me use purple. Purple for this. It's a little bit light. These two will match, but we have to figure out what they are. So do you notice that if I call this A, that I've got 40 plus 90 plus A, 40 plus 90 plus A has to be the full straight line, 180. So 130 plus A equals 180. And then I say, oh, that's 50 degrees. So then this is also 50 degrees, the opposite or vertical angle. So woohoo. Now, if your geometry is really, really rusty and me doing all of this was just like, whoa, that's too much, it's too confusing, then find a tutor, find me, ask us lots of questions. We love answering them. Woohoo. But guess what? We are now officially done. Yay, except you have to do all your homework. But hopefully this made your homework a little bit easier. Remember that if the homework is really frustrating, ask questions. Ask me questions, ask the tutors questions. Tell us you just want to know how to do it, and we will show you until you ask us to stop. Woohoo, guys, you did it. I'm proud of you. You're awesome. Math on.